Section 1.4. Now, I mentioned that simple random samples aren't really all that simple, right? There's difficulty potentially with obtaining the frame of the population, especially if you have a really big population. So that's a potential issue. And, it can just be challenging to obtain a simple random sample. So we have three other common sampling methods that are random sampling methods that are acceptable. And acceptable, what I mean by that is if we use randomness, then our sample is more likely to represent what's really true about the population than if we're not using randomness. So we have simple random samples as one option. We have three other options that we're going to talk about. Those are called stratified samples, systematic samples, and cluster samples. All three of these methods also involve randomness. They're not the same as simple random sample, but it's acceptable randomness so that our sample will most likely reflect what's true about the population. So let's talk about these other sampling methods. So first, the stratified sample. So with a stratified sample, we divide the population into subgroups. And these subgroups are homogeneous, meaning that in order for an individual to go into a subgroup, those individuals have some common characteristic that's important to our research. The groups that we divide the individuals into are called strata. That's a plural, so each group is a stratum, and that is where this word stratified comes from. So a stratified sample is obtained by separating the population into non-overlapping groups called strata, and then obtaining a simple random sample from each stratum. The individuals within each stratum should be homogeneous or similar in some way. So for example, if I wanted to do a political poll, and I wanted to know, do you approve or disapprove of the president's handling of the coronavirus? Well, I suspect that I might get different opinions depending on whether the individual identifies themselves as a Democrat, a Republican, or an independent, let's say. So I would probably divide my population into those three categories, those three strata. So I would first ask individual, do you identify yourself as a Democrat, a Republican, or an independent? And then I would randomly select some individuals from each group. Some Democrats would go into my sample, some Republicans would go into my sample, some independents would go in my sample. Now, the number of individuals from each group that goes into my sample should be in proportion to the size of that group in the population. So in other words, if the population is, say, 35% Democrat, then I would want my sample to be 35% Democrat. If the population is 30% Republican, then I want my sample to be 30% Republican. And then if the rest are independents, that what would be left? That'd be another 35% independents. Then I would want the sample to have 35% independents. So what's a benefit maybe of doing a stratified sample over doing a simple random sample? So if I'm just randomly picking, there's a chance that I could end up with too many or too few of one group. So if I end up with all Democrats in my sample, or a high proportion of Democrats in my sample, then the results that I have are probably not really going to represent what's true from the entire population. So with stratified, I am controlling a little bit more than I am in a simple random sample. I'm controlling the proportions of each groups. Now, that can also be a problem though with stratified. If I think that 35% of the population is Democrat, but if it's really 40% of the population that's Democrat, then I'm going to have the proportions wrong in the sample. So again, my sample is probably not really going to represent the population. So I have to be careful about that, and I got to make sure that my proportions are correct in the population so that I'm correctly representing those groups in the samples as well. So there's pluses and minuses for each of these techniques. So again, a nice benefit of stratified is that I'm controlling things a little more than I can with a simple random sample. So take a look at this example. The CEO of a company is concerned about employee morale. She decides to survey the employees to gather information. The company employs 1,689 full-time hourly employees, 2,576 part-time hourly employees, 258 salaried staff, and 146 managers. The CEO wants to obtain a sample of size n equals 200 with the number of individuals selected from each group, in other words, each stratum, weighted by the population size. Determine the number of employees from each group to be included in the sample. So the first thing I need to do, if I'm going to do a stratified sample here, is I need to figure out what the total is. How many individuals do I have in my population? So if I add up the 1,689 plus the 2,576 plus the 258 plus the 146, altogether there's 4,669 employees. So that's what N is, 4,669. So if I look at the 1,689 full-time employees, so I'm just going to call that full-time hourly employees. So there's 1,689 of them out of 4,669. So 1,689 divided by 4,669, that is about 36%. So this is about 36% of the population. Now the part-time employees, there's 2,576. So 2,576 divided by the 4,669, that is about 55%. So about 55% of the employees are part-time hourly employees. 258 are salaried. So I'm going to put a S for salaried. So 258 divided by the 4,669, that is, if I round to two places, that'd be 6%. So about 6% are salaried. And if I have 146 managers, so we'll put an M for managers. So 146 out of the 4,669, that is about 3%. 3% are managers. And if I've, unless roundings messed me up here, that should add up to 100%. And it looks like it does. So I need 36% of my sample to be full-time hourly employees. I need 55% of my sample to be part-time hourly employees. I need 6% to be salaried employees, and I need 3% to be managers. So if I just take 0.36 times 200, that is 72. So I would need 72 full-time hourly employees included in my sample. And if I take 0.55 times 200, that's 110. So I would need 110 part-time hourly employees in my sample. And if I take 0.06 times 200, that is 12. So I would need 12 salaried employees to be in my sample. And if I take 0.03 times 200, that would be 6. So I would need 6 managers to be in my sample. And if, again, unless roundings mess that up, we should end up with 200. And if you add those up, that does add up to 200. So of my 200 individuals in my sample, I'm going to have 72 full-time hourly employees, 110 part-time hourly employees, 12 salaried employees, and 6 managers included in my sample. So now I would probably use simple random sampling. I would take a list of my full-time employees. I'd assign them numbers from 1 to 1,689, and I'd randomly pick 72 of them. And those 72 would go into my sample. I would number the 2,576 part-time employees from 1 to 2,576, and I'd randomly select 110 of them. I would number my salaried staff from 1 to 258, and I'd randomly select 12 of them. And I'd number my managers from 1 to 146, and I'd randomly select 6 of them. So that is stratified sampling, which again involves randomness, and so it is an acceptable method for obtaining our sample, and it's more likely that it's going to reflect the population. Another method of sampling is called systematic sampling. So a systematic sample is obtained by selecting every kth individual from the population. K's representing a number. So like every 50th individual, every 200th individual, every 73rd individual, or something like that, right? So K is representing how often I'm selecting someone. The first individual selected corresponds to a random number between 1 and K. So if it's every 73rd individual, the first individual would be somewhere between 1 and 73. So the idea with a systematic sampling method is that the randomness kind of occurs naturally. So for example, if you own a grocery store and you want to survey customers, and maybe you know that in a given weekday, you're going to have maybe 3,000 customers. And so you want to get a sample of, say, 100 customers. So you know you're going to have around 3,000 customers in a day, and you want to get a sample of 100 customers. So if I take 3,000 divided by 100, that's going to be 30. So I would maybe select every 30th customer and ask them to complete a survey for me so that I could obtain the information that I'm trying to obtain. So if 30 is my value of K, then the first customer that I'm going to select is going to be in the first 30 from the time I open the door. I would randomly pick some number between 1 and 30. So maybe it's like number 22. So the 22nd customer that checks out that day, I would ask to complete my survey. And then I would skip 30 customers. So the 52nd customer would be the second customer that I would ask to complete my survey. Then I would skip 30 more. So the 82nd customer would be the next customer that I would ask to complete the survey. Then I'd skip 30 more. So the 112th customer would be the next one that I asked to complete the survey, and so on and so on and so on until I get my sample size that I desire. So the steps involved in doing a systematic sample: if possible, approximate the population size. So that's what I was saying about the grocery store problem there, right? If I know that I'm going to have about 3,000 customers in a day, then that's going to be my population size for that day. It's going to be around 3,000, okay? Determine the sample size desired. So I said, how about we do 100? Compute capital N divided by lowercase n and round down to the nearest integer. So I took 3,000 divided by 100. That's where I got 30. Now, most likely that's not going to always divide evenly. So if you have to round, always round down. Never round up. So even if you would have gotten, say, like 32.7, round down to 32, not up to 33. The reason is if you round up, then you're not going to get the sample size that you desire. If you round down, you will. Randomly select a number between 1 and K. So again, K is the value that we're getting here. And so your first individual is going to be in the first K individuals, and call this number P. So P is, there's no real meaning to the letter P there. It's just going to be like the first individual that we are going to start with. So like in my example, I said number 22. Well, that's just randomly selected. And so we have to give it a name. So the author called it P. So P would be the first individual, number P. And then if I take P and add K, that's going to be the number of the second individual. And then if I add K again, that's going to be the number of the third individual. And add K again, that's going to be the fourth individual, and so on and so on and so on. The last individual would be number P plus N minus 1 times K. So like if I wanted my 100th customer, then I could take number 22, because that's what I started with, plus N minus 1, so that'd be 100 minus 1, so 99 times 30. And whatever that is, that would be the number of my last customer that I asked to complete the survey. So let's look at an example to try to help that sink in a little bit. For quality assurance, an inspector at a toy factory needs to gather a sample of 30 toys to inspect from a production line of 5,000 toys as they move single file down a conveyor belt. If systematic sampling is used, determine the numbers of the toys that will make up the sample. So we're going to randomly select 30 toys using systematic sampling. And so again, the purpose here is, if you can visualize it, these toys are being manufactured, they're going down a conveyor belt, and we're going to randomly pick 30 of those toys using a systematic approach. We're told that during this production, they're going to make 5,000 toys. So that's capital N. And we're going to choose a sample of 30 toys to inspect. So that's lowercase n. So I'm going to calculate K by taking the 5,000 divided by 30. So if I take 5,000 divided by 30, that is 166.66666 and so on. So I'm going to round down. That's going to round down to 166. So this is about 166. So I'm going to select every 166th toy. So next, I need to figure out what's going to be the number of the first toy that I inspect. So that first toy needs to be somewhere between number 1 and number 166. So I need to randomly select the number from 1 to 166. So I'm going to just use my calculator to do that. That's going to be what our formula called P. So I'm not going to set a seed value or anything, which I probably should do, but I'm just going to use random integer from 1 to 166. I'm just choosing 1. So that would be, in this case, number 116. So I'm going to start with the 116th toy. That is going to be the first toy in my sample. So number 116 is going to be my first toy. Now, my second toy is going to be number 116 plus 166, because K was 166. So that's 282. So the 282nd toy that comes down the production line will be picked to be inspected. And then the next toy, add 166 again. So that'll be number 448. So the 448th toy is going to be included in my sample. And the next toy will be number 614. And so on and so on and so on. So number 780, number 946, number 1112, and so on and so on and so on. Those would all be included in my sample of 30. What would be the number of the last toy? So the number of my last toy would be my P here, which is 116, plus, now we're looking for 30 toys, right? So the last toy would be 29 times the 166. The 29 is coming from 30 minus 1, 30 being my sample size. So if I figure out what that is, 116 plus 29 times 166, that is number 4,930. So the 4,930th toy would be the 30th toy in my sample. It would be the last toy in my sample. So again, if I were to list all of these out, there would be 30 toys, starting with 116 to 282 and so on. That would be the ones that I would systematically select. So again, this is an acceptable procedure. The sample is most likely going to reflect what's true about the population. So if there's issues in my sample, there will be issues in the population probably, meaning like if there's defects or something like that. But if my sample is all good, you know, all the toys are in good shape, no problems with them, then probably all the toys in the population would also be in good shape. The third sampling method, besides simple random sampling, stratified sampling, and systematic sampling. So the next one is cluster sampling. So I'm going to warn you right off the bat here. A lot of times students confuse cluster sampling with stratified sampling. There are some similarities between cluster sampling and stratified sampling, but there's a huge difference. So I want you to pay attention to the difference. So with stratified sampling, if you'll remember, we divided the population into subgroups based on some common characteristics, some similarity. Okay, so those groups had to be homogeneous, similar, like Democrats, Republican, Independents, or like full-time employee, part-time employed, salaried employed, managers. So the individuals are similar in some way. In cluster sampling, we also divide the population into subgroups. The difference is typically with cluster sampling, those subgroups aren't necessarily going to be homogeneous. So the individuals that end up in a subgroup may or may not be homogeneous. It's not required that they be homogeneous. And in truth, they're usually not going to be homogeneous. But they can be, okay? They can be homogeneous. So what's going to happen is we divide the population into these subgroups, and then we're going to randomly select some of the subgroups. And all of the individuals in the subgroups that are selected go into my sample. So with stratified, we divide into subgroups and we pick some individuals from each group. With cluster sampling, we divide into subgroups and we select some entire groups. So some groups aren't included in the sample, we select some entire groups. So a cluster sample is obtained by selecting all individuals within a randomly selected collection or group of individuals. Caution: stratified and cluster samples are different. In a stratified sample, we divide the population into two or more homogeneous groups, then we obtain a simple random sample from each group. In a cluster sample, we divide the population into either homogeneous or heterogeneous groups, obtain a simple random sample of some of the groups, and survey all individuals in the selected groups. The following figure gives a visual representation of the four effective sampling methods that we've talked about. So this first figure here, we have simple random sampling. So we've got our population, and we have them numbered. We have the individuals numbered, and we randomly select some of the individuals from the population. In this case, we've picked 3. With stratified, we take our population and we divide them into homogeneous subgroups. So like in this case, it looks like we've divided the population into men and women. And then we randomly select some individuals from each subgroup. So a couple of men and a couple of women. With systematic, again, I kind of envision like a lineup of individuals in a systematic sampling approach. So we have our individuals in some kind of a random order, and we pick a starting point and we pick every kth individual. So in this case, we're starting with the second individual, and then we pick every third individual after that. And cluster sampling, we take our population and we divide the population into subgroups. Okay, so our populations here, we've divided it into 6 subgroups, and then we pick some entire groups. So this subgroup got picked. All of the individuals from that subgroup is going to go in my sample. This subgroup got picked. All of the individuals from that subgroup is going to go into my sample. So we're literally picking clusters of individuals, which is why it's called a cluster sample.